Good afternoon, Year 9. We've obviously got a pre-recorded lesson today. Unfortunately, I'm going to have to log on tomorrow as well because I'm on key worker duty then as well. I think we also miss our lesson on Thursday due to PSHE, so I'm really looking forward to actually seeing everyone back in person in school on Friday. I hope you guys are looking forward to that as well. So starter activity today, I've got a hexagon which is labelled A, B, C, D, E, F, and you'll see this quite often in exam questions where the vertices or the corners of the shape are labelled with letters. And I haven't given the answers to these questions, although they are visible on the shape itself. I want us to use our proper angle notation then to write down the values of the angles below, and I'll give us a little starting hint on this. Because we've got angle A, B, C is our first one. You see a little arrow above the B, that means that's where the angle itself is situated. So if you trace a line from A to B to C, then you'll be able to see what angle we're after here. So from A to B to C, the two lines that we actually go along only make one angle there, at 120 degrees. So that's what we're after for the first one. So I'll leave you with that for a few moments. And when you are ready, if you want to pause the video or restart the presentation, and then we can run through the answers to these. Okay, I'm assuming people are ready for the answers. So A to B to C, we just said was going to be 120 degrees. A to D to C, that's going to be A to D to C, almost on the straight lines there from me, which is going to be 60 degrees. Let's change colour to green. B to A to C is 30. That's B to A to C in green there. So you can see it's this 30-degree angle. And then C to A to D we're after. So let's just make a little bit of room for my straight lines. So C to A to D. Again, slightly missing the straight line there, but we get the gist. We've got another 30-degree angle. A to C to D is the next one. So let's draw that on from A to C to D. And you can see we've made the angle here, which is a squared off angle, so it's a 90-degree right angle. We've got O to D to E. So O down to D, down to E, we make that angle there, which is a 60-degree angles, and then E, O, D. Again, if I just draw that on from E to O to D, we get another angle of 60 degrees. So today we're going to be having a look at interior and exterior angles of polygons. So polygon is just a word, if you split it up, it means many, the poly does, and then the gon stands for sort of two-dimensional shape. So it's a many-sided two-dimensional shape. This means that our squares are polygons, triangles are polygons, rectangles are polygons, trapeziums are polygon, and if you go into more sides, then a pentagon is a polygon, a hexagon is a polygon. So anything that's got straight sides and is two-dimensional shape is a polygon. If you have curved sides on a shape, such as if you're looking at a semicircle, that doesn't class as a polygon. So developing students today are going to have a look at exterior angles. These are going to be the angles outside a shape. Secure students will be looking at interior, that's the angles inside a polygon. Then excelling students are going to be doing some problem solving with that. So today we're going to have a look at, start off with a polygon of a quadrilateral which has four sides. So this one is an irregular polygon, an irregular quadrilateral, because it doesn't have equal sides, it doesn't have equal angles. We can have a look at some of the properties of it. And it can be split into two triangles. Now you might have done this in previous years. I know some of the students I've taught for a good while have seen this before. If you join one corner of your shape, one vertex up to all of the others, you actually start to split your shape up into two triangles. Now that's obviously in this case starting from this corner, joined up to there, joined up to there, and joined up to there. You can see that we've got two triangles that the shape split into. And if you were to join it a different way, you'd still get the two triangles, but it's from one vertex or one corner to all of the others. Now we know that the angles in a triangle add up to 180. So if you've got two triangles that your shape split up into, it'll add up to two lots of 180, in this case 360. And this is for any four-sided shape. So any four-sided shape has angles that add up to 360. So in this four-sided shape, P plus Q plus R plus S, so the orange plus blue plus green plus purple angles all add up to 360 degrees. We can have a look at this in a little bit more depth in a second. If our shape has four sides, it can be split into two triangles. And there's a link here that the number of triangles is always 2 less than the number of sides. So a six-sided shape would be split into four triangles, and we do 4 times 180 to see what the angles add up to, the angle sum of that shape. And if it had 8 sides, we'd then have 6 triangles, so you'd need to do 6 times 180, and that would then reveal the interior angle sum, or that means the total of the angles inside the shape. So this can be really useful for working out the angles inside any shape going. So if we look at another example here, a pentagon has 5 sides. So if we were to do the same process, and some of us might want to do this visually, some of us might remember the rule from the previous slide here, a pentagon can be split into 3 triangles. That's 2 less than the sides. It has 5 sides, 5 take 2 is 3, so 3 triangles. And again, we can demonstrate that with the lines on if you feel more comfortable drawing them in. So if a shape is split into 3 triangles, then of course its angle sum, the total of those inside angles of the shape, is 3 times 180, which is 540. So in this case, 5 angles here, A plus B plus C plus D plus E, are all going to equal 540. And this works for absolutely any one of these polygons that has 5 sides, so any pentagon has to add up to 540. Likewise, if you went for a 12-sided shape, then if you had 12 sides, then we'd have 10 triangles, and therefore we'd be doing 10 times 180, so 1800 degrees would be the sum of the angles inside the shape, or the sum of interior angles for that shape. So we should be able to very quickly work out what the angle sum of any shape is. Now if you have a regular shape, then that means that all of the angles are equal. So if I had a regular 12-sided shape, then if I wanted to find out what one of the interior angles was, then I'd be doing my 1800, and because there are 12 sides, I'd have to divide my answer by 12, and this means that in a regular polygon with this many sides, each of the interior angles would be 150. And that's if it's a regular one with equal sides. Remember, regular in common way of speaking just means that it's a normal one, but regular in mathematical speak means that it's a very specific type of shape with all equal sides and all equal angles. Right, we can also have a look at the exterior angles for a shape. So the exterior angles, you might imagine if you're walking along a side, so if I was walking along the side here, along this way, they tell you how much you need to turn to get back on track with walking around the shape. So if I walk along this red line here, I would have to turn through angle F to get back on track to now walk down the next side of the shape. And if I'm walking here, I'd now need to turn through angle G to tell me how to walk along the next side of the shape. Then I would need to walk through angle H, so turn through angle H to walk down this side, and then turn through angle I to walk down this side. Now, the fact that we've turned a big circle around our shape should reveal one of the properties about our exterior angles. So the property is that all of our exterior angles all add up to 360, because turning through all of them will allow you to walk all the way around a shape. And if there were more interior angles, you'd still add up all of them in order to make that 360. Now, we might also then be able to have a look at another property of them. How we've just had a look at the interior angles inside a shape, and then this property is that each vertex or each corner, the interior angle plus the exterior angle equals 180. So I could label those up, which colour is going to work? Bright red, I think. So if I was looking at angle F here, so angle F is the exterior angle, and the angle I've labelled up here is the interior, and you can see that they make a straight line there, so they'd add up to 180. Also angle G here, and the one next to it, this would be the interior because it's inside the shape, and this would be the exterior because it's outside, and together they're on a straight line, so they're going to add up to 180. Likewise with angle H here, H is the exterior and the interior inside on a straight line, add up to 180. I and this one here, interior and I is the exterior on a straight line, add to 180, and here on a straight line, add to 180. So this is another property that we might have with our shapes. So putting all of this together, we might be able to talk about shapes. Now, if I've got a pentagon here, this is going to be a regular pentagon, so it's going to have equal sides, and therefore all of the angles are going to be equal in size. We can work out quite a few things about it. So I've got 5 sides. That means that I can either do this by drawing, so let's go to a different colour just for a second, let's go to purple. So if I pick one corner and join it to all of the others, or just take 2 from the number of sides, I can see this shape split into 3 triangles. That means that the sum of interior angles is 3 times 180, which is 540 degrees. So I know that the total of all of those interior angles is 540. Now, if there are 5 of them, I now need to do 540 divided by 5, because there's 5 angles there. I'll do that separately. 540 divided by 5 equals 108. So that means that each of these angles here is 108 degrees. Now, we're not going to be asked for it in this question, but we could also then have a look at the exterior angles. And then if I was to carry on these straight lines, so if I'm walking along this side, then I'd need to turn through this angle to get the exterior. If I'm then walking along here, I'll turn through this to get the exterior, walk along here, turn for the exterior, turn for the exterior, and turn for the exterior. You could do it the other way around. I've done it clockwise here, but you could go anti-clockwise. And then, because we're on a straight line, if our angle x here is 108, then this one over here must be 72 degrees, because I had to make 180. So that's 72, that's 72, that's 72, and that's 72. And we can just double check that we've got this right, because there's 5 exterior angles, and 5 lots of 72. Well, indeed, it's 360. Remember, you must have known that the exterior angles always add to 360. So we can work out quite a few bits to a shape from one starting point of just knowing the number of sides. We could also work the other way. Here I've got an interior angle from a regular polygon. So the angle when the next side comes along is also 175. The angle when this side moves is also 175. And we want to know the number of sides it has. Well, here I know that the interior angle is 175, so I could work out the exterior angle. It must add up to make 180, so that's going to be 5 degrees. And it says work out the number of sides the polygon has. Well, the number of sides is equal to the number of exterior angles. And in this case, if the exterior angles all add up to 360, I need to do 360 divided by the exterior angle here. We know they're all going to be the same because it's a regular polygon. And 360 divided by 5 is 72. So this shape would actually have 72 sides. So the angle sum we could go for as well. It's not asked for in this question, but if we know there's 72 sides, there's going to be 72 interior angles as well. So we do 175 times 72. Is 12,600. So the sum of interior angles equals 12,600. So knowing just a couple of things, knowing that a shape can be split into 2 fewer triangles than the amount of sides, and knowing that the exterior angles all add up to 360 can actually help us to work out all sorts of things in between and work from sides to angles or from angles back to the amount of sides, so we can work forwards and backwards with this. So I'm going to ask you to have a look at the activity that we've got. It's going to be our learning cycle for week 1 at the moment. We're going to be now moving into. It's handy for us coming back to school, starting a new learning cycle. and then I'd like us to just have a go at the red or the amber or the green, and there's an extension activity there as well if you need at the end. Just remember the red, the amber and the green activities are all the same. It's just the amount of help that you get with them. So the red activity at almost at the bottom of the sheet is going to have a fair bit of help. The amber activity will have some help, and the green one at the start of the sheet is going to have no help at all. Now the answers to these are on the next slides on the PowerPoint, so make sure that you are just self-marking before you upload your work to Class Notebook. And again, if you can't get Class Notebook to work just yet, just make sure that you have got all of your files ready for Friday. So as we come into school on Friday, and we might have access to the Chromebooks, or that might be the week after maybe, and we'll get any photographs that need to be taken, or I'll talk people through Class Notebook and be able to upload everything as we need to Class Notebook from there. So good luck with the work. Again, I am on key worker duty today, so please email me if you do need a hand, but you might need to be patient just a few minutes depending on what I'm doing in order to get a response. Thank you very much, and I'll speak to you again tomorrow.